Fiber-reinforced composites manufacturing can be achieved through several processes, including compression molding, bladder molding, wet layup, mandrel molding, chopper gun, autoclave and vacuum bag, filament winding, and pultrusion, for continuous profiles, hand layup for manual layering in a mold, and variation of layup by spray molding which involves spraying fibers and resin. The choice of method depends on the desired product shape and scale, with pultrusion used for automated production of long shapes and hand layup for smaller or more complex parts. The cost of establishing a fiber-reinforced composites manufacturing unit varies significantly based on factors like the type of composite, production scale, and level of automation. A basic, low-volume operation using hand layup could begin with an investment of few $1,000s, while a large, automated, high-volume production line can require $500,000s or more for equipment alone. A quick overview is presented here. The worldwide composites market is experiencing steady growth, with overall revenue projected to increase substantially over the coming decade due to demand in high-growth sectors. This slide shows the expected worldwide revenue generation of $220 billion by year 2030. Hence, the intelligent decision is to enter in the composites manufacturing market immediately. A quick tour of various manufacturing techniques to select from is presented in this micro-lecture. This process is suitable for low-volume production and has lower initial equipment costs, as it requires minimal machinery. However, it is labor-intensive, which increases per-part costs for higher volumes. It is a manual method where layers of reinforcement, like mats or fabrics, are placed in a mold, and then resin is applied by hand to impregnate the fibers. This is used for creating complex or customized shapes. Spray molding is similar to hand layup, but uses a spray gun to simultaneously apply chopped fibers and resin onto a mold. This is efficient for creating large, flat sheets for applications like doors and grills. These methods are more automated and better for higher volume, repeatable parts. Initial capital costs are higher due to specialized equipment, but labor costs per part are much lower. These are used for higher production rates and better dimensional control. Resin transfer molding, RTM, is a process where dry fiber reinforcement is placed in a closed mold, and then liquid resin is injected under pressure to impregnate the fibers. Manufacturing techniques like filament winding and weaving preforms are optimized for continuous fibers and high-performance composites. Pultrusion is an automated, continuous process where fibers are pulled through a resin bath and then a heated die to form a specific shape, such as profiles, rods, or bars. A turnkey glass fiber reinforced polymer, GFRP, rebar pultrusion plant can range from $100,000s for a basic system to over $500,000s for highly automated versions. These high-precision techniques have high degree of repeatability and suitable for aerospace and high-end applications. AFP is a high-tech and automated process used in the aerospace industry. It requires a significant capital investment for the machinery but reduces labor and material waste. Similarly, 3D printing is an added innovation for manufacturing high-quality fiber composites. Offer good control of fiber content and low voids. Vacuum bagging and infusion techniques produce laminate structures without any dislocations or air entrapment. These are therefore preferred for applications requiring same fiber concentrations every time and low voids. Prepregs ensure high performance, precise control over resin content and curing. Recent advances are aimed at out-of-autoclave curing to reduce manufacturing costs and reduced energy consumption. However, machines and large autoclaves can represent a major investment. For niche or high-performance requirements, advanced technique like centrifugal casting, sheet or bulk molding are applied. Sheet molding compound, SMC, and centrifugal casting are two distinct manufacturing processes for creating fiber composites, each suited for different part geometries and production volumes. All the techniques flashed on the screen require high-budget investment. In addition to the main equipment and allied services, there are other essential expenses that must be considered before selecting or starting any manufacturing business. 3 things that need special attention are the cost of land and space for the facility/labor cost is also an important factor. Last but not the least, general expenses like administrative costs, taxes, and insurance are also part of the overall cost. The list of future lectures are shown in this slide. This will encompass all the important aspects of fiber-reinforced glass and carbon fiber manufacturing techniques. Stay tuned on the YouTube channel of Technology Education and Mentoring Center.